Hi, welcome to another episode of This Is My Architecture. I'm David John and I have with me Lakan from ZS Associates. Hi Lakan, welcome to the show.
Thank you so much for having
All right, already we see the standard stuff. We see the things that people love to do, love to use. We see SQS, message queue, identity and access management. We see Elastic MapReduce. Well, they're most likely, I think you can also run Spark on this. Users, EC2 instances, Kubernetes cluster, data catalog, data store, Postgres, SQL, S3. All right, interesting.
me.
So let's get started. Tell us something about ZS Associates.
ZS is a global professional services firm where we provide technology, analytics, and strategy consulting to various clients across the industry. We have a keen focus on life sciences and their various functions.
Great. So we are here to talk about your self-service enterprise data engineering platform. What does this platform do?
Yeah, so for in life sciences, if it start to grow, different function becomes more and more data driven. They often start to face challenges while scaling their analytics journey. For example, they start to face challenge in building those data integration and ingestion pipeline. Second challenge they face is the turnaround time they require to spin up the infrastructure, which is consistent, compliant, secure, because it often requires deep tech skill or multiple approval across different agencies. Third challenge faced by data analysts and data scientists by time they took to discover data sets in a data lake and get access to the data sets. What we have here.
Okay, that's something that you see a lot. And spinning up infrastructure takes time, is complicated. And getting insight into data sets, that's also something you want to have. And he said that in the first part, the scaling the analytics, right? Scaling the analytics insights of what they're getting. And that's the main thing. The infrastructure and so on is just inconvenience, but actually getting analytics results and scaling that's the most important part here.
Is a self-service enterprise data engineering platform which tries to solve those typical challenge with the key goal of shorter time to market for these functions, security at scale, all with the optimal cost.
Yeah, of course. And that's what I meant. Time to market for, okay, we have all that data, or we have some data, we want to bring out a product. We want to have something self-service for engineers where they can build stuff themselves and not have to rely on infrastructure or the IT people. Okay.
Oh, I completely agree with the challenges you've highlighted, and that's some good set of goals you set right at the start. So let's dive a bit deeper. So who are these users and how do they interact with the platform?
Yeah, so our first user are data engineer who want to set up an infrastructure for their application. Let's say, so they log into our self-service web portal where they select the type of infrastructure. It could be a batch ETL, it could be real-time change data capture type of a pipeline, or it could be a custom multi-tier web application. Once they make the choice, they also have to provide cost center or project code information, which we eventually use to charge back. Once this selection is
that sounds like this is a web UI. A web UI website, something that is hosted there. Websites, yeah. Because why would you log into an EC2 then? Well, you could because you want to execute scripts, but
made, our portal makes a REST request to EKS, where a service running on EKS creates a request record in Postgre with all the metadata information, and then creates an event on SQS, which in turn trigger a automation workflow for infrastructure provisioning.
okay, so that's actually cool. That's what I meant here. You don't need to have a lot of knowledge here, a lot of business. No, of technical coding and so on. You need a user interface. People add in the information from the user interface, and then the user interface goes over here, and through EKS it starts a job, and that job is there for deploying the resources, deploying the platform. And the metadata that you entered here in EC2 and that EKS got is actually written to Postgres, and this here, that's your metadata here. Metadata. And the metadata is also, or the data is then going to the queue, and the queue is in charge of, I'm guessing there will be some runner then who actually then deploys the architecture. Self-service for engineers, but not self-service analytics for business end users. So it's a combination most likely, because the engineering team is creating this and they create then the resources for the analytics team, and the amount of self-service that the analytics team does. What would be some examples for the self-service for business end users and so on? I don't know, Sunny.
After the workflow is completed, again, the service sends a notification using SES with all the information about the infrastructure provision back to the request tree.
So that's impressive automation, I should say. So I want to dive a little.
So they didn't really explain what happens here, right? They didn't really explain where this queue is going. Because yes, once everything is done, this is just an email. So this will be an email here, but I'm not sure. It feels like they yeah.
A little bit deeper. I want to know what happens when the user actually submits the job.
Yeah, so as I said, there is an event sent to SQS which provisions the infrastructure. What happens here is there is another job in EKS which picked up this message and take various action based on the requested infrastructure type. Let's say it is a batch ETL. The first action it will take is creating an EMR cluster. Then it will create various databases in Glue catalog. Then it creates S3 buckets and launches an EC2 with containerized Airflow or NiFi, where data engineer will be running those data engineering pipelines. And then lastly, create IAM role, which integrates all of these resources. At the end,
that's actually very cool. And I like that how they build it, that this so that this basically flows back and EKS is listening to that message queue. And this way you cannot, how should I say this? Nothing gets lost, right? Users are, nothing gets lost. Users are creating their platforms, creating their jobs, and it's going to go to EKS and immediately to the queue, and then the actual runner that spins off everything, that configures everything, then one by one takes it out of the queue and then executes the scripts that they prepared to then with code, infrastructure as code, basically create the infrastructure. Like I said, EDMR jobs, Glue catalogs, S3, EKS, EC2 instances, and then once everything is ready, you need to give people access. And so the metadata that this has, most likely this has also the users, right? So this has user information, and with that user information, the job then uses the IAM and then automatically configures access to the people, so they can actually use these resources that the system created for them. It's a cool use case. What's the role of SAS here? The role of SAS, they said, is just once everything is done, EKS is going to send a message or information to SAS, which then writes email to the basically customer and tells and shows that everything is set up. Yeah, that is completely email driven.
At the end, it will again send a message using SES with all the information about project resources provisioned and how to access them back to the user.
Yeah, that's where
It's
we
good.
were.
The orchestration pipeline uses a lot of AWS services. It's fantastic. But with this much of automation, I'm curious to understand, how do you manage the data governance, security, and discovery part of it?
Sure. Well, first thing I'll tell is all of our data sits on various S3 bucket across AWS account. What we have done is control the access to this S3 bucket through Glue Catalog. So everything accessed through Glue Catalog. We have crawlers running in EKS, which crawls the changes in metadata and make it available in our self-service portal as a data discovery dashboard. That's when users like data analysts and scientists come to this dashboard, selects different data sets they need access to, and hit request. After this,
Okay, so as I said, I was already on the right track. This is more of a dashboard here, where engineers start up everything, and where scientists or analysts have access to actually require or write an application for access to that data. And it's also interesting what he said. Like, these buckets are safe, these S3 buckets, but people don't have access directly to the S3 buckets, but through Glue Catalog. That's actually a cool use case, because for the user doesn't know the data is within the bucket, can use it through Glue. Most likely they also use something like Athena or Redshift Spectrum then for that. That's nice. Okay, that's cool.
most of the automation is same as infrastructure provisioning, with the key change in the requested data set has to be approved by data owner. So before we provision anything, we use SES to notify data owner to accept those requests. Once they accept it, it triggers an event in SQS, again followed by a job running in EKS, which then updates IAM role, or it updates ranger policy if it requires fine-grained access control. And again, at the end, sends the same information about the data access provision back to the requester.
This is a nice solution, isn't it? It's a nice solution. There are a lot of arrows here, because the EKS is the main point of interest here, the management, let's say, here. And you have your tools around, like a message queue or here SES, that actually then queue the jobs and that notify the users. So yeah, so this way, that's also why SQS is used here, because it's going to be a simple entry point to configuring the whole platform, right? SQS is used when the engineer goes here, the engineer makes that request and sends the request for provisioning of the platform. But also, if, as he said here with that arrow, if a user gets a request and then this request also then goes through and goes here back into, should have made this red, and then gives access to people, to other users, or accepts access. So it's that's a nice solution, and that's a cool solution to use. In general, and a cool solution to use message queues and to use EKS here. That's self-service, and that's also what. Who asked that before? Amit? Somebody asked, is that here, Sunny? Self-service for analytics for business or end users? That's also for then the end users. That's also analytics for the analyst, for instance, because the analyst is going to, once new data is coming in here, that EC2 is going to update the catalog and is going to show this information here in the user interface, and then people can actually apply here to access that data. Right. That's cool, right?
Right. So you even have manual approvals in your orchestration pipeline.
Yeah.
And the way I see it, it's the Glue Catalog and IAM, which are the crucial services which help you to data discovery, security, and governance. Fantastic. I'm interested to know the scale of this platform. Do you want to talk about it?
Sure. At this point in time, our EKS hosts 800 plus microservices. Of course, many of these microservices are supporting these workflows and UI portal, but large part of this is reusable data engineering services. For example, so there are services for computer lifecycle management, there are services for different data processing, there are services for data quality rules, running quality rules on data sets. All these reusable services, on a rough scale, we receive millions of API requests every month, and hundreds of data access requests per month from data analysts and data scientists.
So I assume your platform services are running on EKS at scale, and your application setup, all the applications are running in EMR. Fantastic. So what were some key challenges which this platform has addressed?
So it's not like they use a message queue here because there is so much data, right? It's to have it in an organized way, to take care of requests in an organized way. I like that.
For you.
Yeah, like I said in before, these are some of our key goals from the platform, which is shorter time to market for our functional teams. Right? The way we achieved is automating data access governance workflow, which before this used to take 6 weeks. Now it takes few hours with a human in the loop who approves the request. The infrastructure provisioning, which used to take month with all the approvals needed from security and compliance agencies.
I mean, it's an event-driven system. Yeah, that's an event-driven system. And in that system, the event is created by users. So it's I mean, that's cool.
Now it takes few minutes. The other data engineering reusable services help reduce the build of data engineering pipeline by 30 to 40% for our engineers. Secondly, the security at scale. We have baked in all the security requirement needed to provision this provision infrastructure and governance flow. For example, anonymization, masking, encryption, and fine-grained access control. We control the cost by using auto-scaling capability of EKS and EMR.
That's very clever. And that's a clever use of these two because you can use auto-scaling. Also for EC2, you can use auto-scaling, and S3 doesn't need auto-scaling. Glue data catalog doesn't need auto-scaling. This is most likely these are not that, don't need a lot of scaling. So Postgres, it's a good idea to do it like that.
Additionally, everything getting provisioned through this platform is tagged, which gives the functional team ability to keep a check on expenses every month.
Oh, it's fantastic. This goal seemed very challenging at the start of the conversation, but I'm really surprised how your data engineering platform was able to meet those goals using so many AWS services. Thanks a lot, Lakan, for being on the show. Thank you for watching This Is My Architecture.
Thanks, guys. So nice. I mean, that's everything you need. You have identity and access control. You have basically secured data or safe data in S3. Of course, this is mainly for analytics use cases, where you drop the data, where the data is in a structured format. Does it use Airflow? No, in that they don't use Airflow, because why would they use Airflow here? They don't really require Airflow because it's an event-driven system. So the events are coming in through SQS here, and EKS then executes a list of let's say a list of commands to spin up the infrastructure for the projects, to spin up the infrastructure for the engineers. So you don't really use that here in this use case. It's an event-driven system. Latency of spinning up clusters and glue jobs. Well, yes, you have latency of spinning up the whole thing. The thing is, if you start a new project and if you want to use this, let's say this takes an hour. Who cares? Take an hour to spin up the whole thing, and from there on then use it. Of course, it would be good if that's quicker, but the actual processing is, once EMR is set up, and once you can process data with EMR, then you can directly log into EMR and work there, and have your scripts run in EMR and process the data, basically accessing the Glue data catalog and accessing the data here vertically, right? So that, because that's the only place where data is laying for all the users. The Postgres here is just for managing metadata for the actual process. You could, of course, you could run, if you want to spin up EC2, you could spin up EC2. And there's also there are services on there's a Airflow service on AWS, and they're just showing these. I'm guessing you could also configure here, within your Kubernetes, you could configure that. Once you set up this, you could spin up Airflow on AWS. This example here is just with S3. It doesn't have a Redshift or something here. But the general idea is basically these 3 services here are the center for everything. Your UI, where you either host new infrastructure or you request access for data. The message queue, that is queuing jobs for EKS, and actually EKS that spins up the infrastructure and manages and sends the metadata to a database. So these are the key services here. You could say SAS as well, because SAS is the messaging for the end users. You could go without that if you say, okay, I just have the interface here. But of course, it's nicer if you say, if you want to notify people, then email is still the optimal way of doing it.